Hello students, this lecture will be on matrix, its definition and types and activities that we can do inside of it. So let's begin. Let's begin with definition. In mathematics, a matrix is a rectangular array that consists of numbers, expressions or symbols arranged in rows and columns that represent the mathematical object or just properties of these objects. For example, this is a matrix that consists of 3 columns and 2 rows, so we can say that dimension of this matrix is 2 to 3. Let's begin with Cramer's rule. Cramer's rule is an explicit formula for the solution of system of linear algebraic equation valid for the cases where the number of equation is equal to the number of unknowns and the determinant is not null. So let's solve our matrix as it's shown in an example. We have this system and we have 2 rows and 2 unknowns, so its thing can be solved by Cramer's rule. Let's calculate the main determinant of this matrix. So it will be like that. So we put here coefficients of this matrix and then applying rule of diagonals, one multiply with minus 4, then minus 2 multiplied by 3, minus 4 plus 6, and we have 2 as a result. Then we calculate determinants for unknown x, delta x. So we put here, instead of coefficient x is always 1 and 7, so this column goes 1, 7, minus 2, minus 4, and then we proceed as was shown above, one diagonal, then minus other diagonal this way. Okay. So we have as a result minus 4 plus 14, and it goes to 10, and we apply the same for y. 1, 3. Then we replace this column by this column. And we have 7 minus 3, and this is 4. After this, we define our unknown as x. The determinant calculated by x 10 and divide it by the main determinant 2, and it will go to 5, and y will be like determinant of x and divide by determinant of matrix. So this will be 4 divided by 2, and it makes 2. So we have answers 5 and 2 in our solution of matrix by Cramer's rule. Thank you for your attention. Now the next will be the method of Gauss. One of the ways to find a solution for system of linear equation is Gauss method based on elimination of some rows and some unknowns or coefficients of these unknowns. So let's begin with an example. We have system of 2 equations and we put it as matrix. 1 minus 4 and 1 and minus. So what we can do? We can multiply a system, we can add some numbers to other part of systems, and we can replace by results system. There are several activities to do with it. So now the best way to eliminate x is to multiply the first equation by minus 3 and add 2 equations. So we put that right here. 3, and we have minus 6, we have 3, and we have 12. And here we 6 and 1 and minus. Then we add 2 equations and put it in the second row. The first row will be intact. So we have this matrix, then we can divide our second row by 2. And then we have 0, 2, and 3. Then we can divide the first row by 3 and have system like -2, then 1 and 4, and the second row will be the same. 0, 2 and 3. Then we get back to our first equations and put here the unknowns. So we have and here we have from the second equation we can easily get this unknown y, and after this we put it in our first equation. So we have then we put 1.5 in the second part of equation with minus, and we have and so we have x minus 1.25. So we have the solution for our system, and one of the methods of finding solution of matrix and calculating its determinant is decomposing. As you see, we can decompose matrix by any row. So let's begin with the first. As an example, if we have matrix like this, then we could solve it by making these activities as this element A11, and then we put this area in matrix 2. Then we have such weights for it plus minus plus. Then we have minus, and then we have one to the first row, sorry. And then so this is an equation for solving of matrix, and in next slide we can solve it with numbers. So this is a typical matrix, and we write down it like I explained before. By decomposition by the first row, it will be three, then we have this minus, and the last one. Then we calculate by diagonals as usual. This is multiple, not plus. Then the main diagonal, 2 by 3 minus 3 by 3, and plus 2 by 4 minus 5 by 3. So let's put it together, and we have 3, then we have 3 minus 3 and plus minus 7. So we have 9, and we have plus 6 minus 7, which gets us to 8. So we find the determinant of this matrix, that is 8. So thank you for your attention. See you on next lecture.